Hi there. Today let's go through the problem number 4 from LeetCode. The problem definition is as follows. Therefore, we are given two sorted arrays, which are named nums1 and nums2, and the size of them is m and n respectively. The function has to return the median of the two sorted array. Therefore, the problem definition seems to be very small and simple, but there is a lot of things that we need to understand before go. And the follow-up is that the overall runtime complexity should be O of log of m plus n. Therefore, this is the follow-up to this particular question. Therefore, let's go through a couple of examples before we dive into the solution. Therefore, let's assume here, right, the input is nums1 is 1 and 3 and the nums2 is just 2, right? Therefore, if we these two are both sorted arrays in themselves, and if you take the merged array out of these, right, then it would look 1, 2, 3, and the median is the middle number. Therefore, in this case, since it is odd, there is only one middle number, and that is the median. If it were even, right, like for example in this case where 1 and 2 and 3 and 4 are taken and the merged array is 1, 2, 3, 4, right, then there are two middle numbers now, 2 and 3, right? And in this case actually the median actually is the average of the middle two numbers. In the the answer is 2.5. Therefore, going through the prototype, right, we are given pointer to nums1 and nums2 and the size of both nums1 and nums2, and the median of course is a double because it's a real number. We have to return that. Okay. Therefore, before we go into coding and understanding it further, right, how we are going to solve, let's see how can we merge two sorted arrays, right? Therefore, the first solution what we want to discuss or we want to solve is try to find algorithm to merge two arrays and then find a median. Therefore, let's go through that. Say for example two arrays that are given, right, like for example nums1, one is say 1, 4, 7, 9, and nums2 is say 3, 8, 10 and 15, right? Then the way we actually would try to merge it is using two pointer method or two index method, whether we are choosing a pointer or an index, it depends on that. Therefore, the method involves as such. Therefore, we take two pointers or index. Since I'm going to solve it by index method, I'll keep on telling index from now on. Therefore, we point it to the first element of both the index. Okay. Therefore, these are the two pointers, the arrows, whichever I am showing it over here, right? And we compare them. Therefore, whichever is the smallest, right, we copy it to the merged array or the resultant array, right? And we move that particular pointer further. Therefore, this pointer now will move over here. Then next we compare again these two elements 3 and 4. Whichever is the smallest goes to the resultant array 3, right? Once we copy that, right, that particular pointer we increment it to the next one. Now we compare 4 and 8, right? Next is 4. This is the smallest. Then we the pointer I have to move now, sorry, right? Now it will point to 7. Now we again compare 7 and 8. The smallest one is 7 in that. Therefore, I move this pointer over here now. Now we compare 8 and 9. 8 is the smallest in that, right? Therefore, I'll copy 8 here and move the pointer and so on, right? Therefore, the next element will be 9, 10 and 15, and we finally have over the resultant array. Therefore, this is a resultant merged array. Now to find the median here, right? Therefore, how many numbers are there? Therefore, here it is 8, right? The total elements here is 8. Therefore, if it is 8, then it means that we have two middle elements. Therefore, if you go by it, right, therefore 7 and 8, these two are the middle elements actually, right? Therefore the median here is 7 plus 8 divided by 2, that is 7.5. Therefore this is the method we are going to follow. This will I'll code up and we can look into the solution. Now say for example here the median was 7 and 8. Say we had odd example here was of the even. Say we had an odd number, right? Say my array was say let's take 1 4 7 9 and let's make the other array shorter, 3 8 10, right? We'll use the same two pointer method even for an odd array, right? And the resultant array here will be 1 3 4 7 8 9 and 10, right? And the middle element here is 7. Therefore the median is 7 in this case. Therefore this is the method. Therefore to find the median, right, in coding, right, what do we know? The best way to find the median is there is one simple formula for that to find the median. The formula is as such. Therefore this will work even for even as well as odd. We can write a separate formula for the expression for even and odd, but this will work for both, and I want to show you that. Therefore the median actually is the average of, right, it is the average of two things, okay? What is it average of? One is whatever is the number, right, in the resultant array, right, of total number of elements, right, minus 1 plus total number of elements divided by 2, divided by 2, right? If I take the index of these two things, right, the average of it is nothing but the median. Therefore if you go again, right, and try to see whether this we can do, therefore I need to find two elements, one which is at total element minus 1 by 2, okay? Therefore let's see that. What is the total number of elements here? It is 8. 8 minus 1 is 7, right? 7 by 2 is 3. Therefore what is at third index? 7. Okay, the first element I got. The second element is actually at index total by 2, that is 8 by 2, that is at index 4, that is 8. Therefore the median is 7 plus 8 by 2, that's it. Therefore we are getting the correct answer here in case of even. Say in case of odd, what will happen? The total number of elements over here is how much? 1 2 3 4 5 6 7, right? 7 is the total number of elements. Therefore total number of elements here is 7 in this particular case. Now let's find out, let's use the same formula. Therefore 7 minus 1 by 2 is 7 minus 1 is 6. 6 by 2 is 3. 0 1 2 3, right? And 7 by 2 is again 3 because we are doing an integer division. Therefore 3 plus 3 or n of 3 plus 3 divided by 2, right? Therefore n of 3 is 7. 7 plus 7 divided by 2, which is again a 7. Therefore this formula works both for even and odd. Therefore we'll use this to find the median once we get the resultant array. Therefore let's now code up this particular discussion, whatever we had, right, into a solution. Therefore let's copy our prototype into our favorite editor, okay? I'm going to include, let me increase the font a bit, stdio.h. Yeah, the first and foremost thing, right, we need to do is actually have a resultant array alloced, right? We have to malloc for that. Therefore the resultant array, let's call it as res, and I have to malloc the each element in that array is of size int, and the size of the total array is actually nums1, size plus nums2 size. Therefore this is the malloc that is required, and I have to check if the resultant array, if it is null, then I am having an issue, right? Then I need to return some value. Apart from that, it is quite possible that both nums1 and nums2 can be null, right, as an input array. Then also I can't calculate the median by any formula. Therefore this would be the other condition, right? If nums1 equal to null, and if one of them is null, that is, I think, fine, we should be able to handle it. But if both are null, we will not be able to handle it. Therefore I just want to return 0.0, just some number. It can be even -1 or whatever, right? Doesn't matter. I just don't want to go through with the code and finally crash or something. I want to just return it right away. Next actually is we need two pointers, two indexes to move through both of the arrays, right? What we just discussed, the two index method. Therefore let me call those index as I1 and I2. I also need an index to move around the result, right? Let me call that as a IR. Therefore let me initialize it to 0, all of them to 0 actually. Now let me write a while loop where I1 is less than nums1 size, nums1 size, I am writing to, okay, and the other condition is that I2 also should be equal to nums2 size, right? This is where this while loop will go through, and the condition here is that if say nums1 of I1, right, is less than nums2 of I2, right, if the numbers in those particular arrays, if they are less, then I know that I need, in this case I have to copy whatever is a number at nums1, right? Therefore R of the resultant array, right, which is res of IR is the index for this. I have to increment it because I am placing something here. Therefore nums1 of I1 plus plus, right? I have to increment both of them. In the else case, right, then I know that, oh, nums2 is smaller. In that case the same thing, but here I would be copying the item from nums2, right? This is how it will go through. Now since if the arrays are not equal, right, then it is possible that after all these comparison we'll run out of all elements from one of the array and there will be some remaining element of the other array, right? Therefore that we can just copy it right away to the result because it's already sorted. Therefore I'll write two while loops in case say I1 is still remaining, right? It's still less than nums1, then I know that I have to still copy whatever is there from I1, and the other equally another possible condition is that I2 the index I2 also might not have reached the end, right? In that case I'll copy the nums2 size, right, into IR, right? And what is our result now? Yeah, result is average, right? Therefore let me okay, instead of that let me directly return the result. Okay, we can calculate the result, but we can directly return, right? Therefore here I have to write it's total minus 1 by 2, right? Total is nums1 size plus nums2 size, nums2 size minus 1 by 2, right? This is an integer division, plus result of nums1 size nums1 size plus nums2 size by 2, right? I have to put a bracket here, and finally the result is actually the whole thing is divided by 2.0. The reason I am putting 2.0 is I want a floating division here, not an integer division. That is the reason, because median can be a point, right? And this is the result. Therefore, this is the whole solution. Therefore, let's quickly also write a driver function for this so that we could test it here. And I need two sorted arrays, right? Therefore, let me take it as int a. Therefore, it's an array, sorry. And say I take 1 and 2, and the other array, say B array, is say 3 and 4, and say the median is called as med, and the median is equal to, find the median of sorted array. I need to pass a comma size of a divided by size of a of 0, b comma size of b divided by size of b of 0. Printf median is percentage f, and I'll print the value of median and return 0. So let's quickly compile this. Yeah, for malloc we need to include stdlib.h. Therefore, let me do that quickly. I forgot that. Okay, it compiles cleanly. Let's see. Okay, the answer is coming as 2.5. Let's see whether it has worked properly. Yeah, therefore the resultant array is 1, 2, 3, 4, and the median is the average of 2 and 3, which is 2.5. Therefore, looks like this brute force method or the to index method is working. Therefore, let's quickly submit it and see if it works also in. Let's paste it here. Let me quickly run the code before I submit it. Yeah, therefore it is running. Okay, therefore this is one of the solutions. Therefore, going through what is the complexity of this particular code. Therefore, since we are allocating memory here, the complexity, the size optimization is we are allocating for both, right, of m and n size. Therefore, this is of O of m plus n from space optimization, and when it comes to the runtime optimization, we are actually visiting both the arrays, right, at least once. Therefore, that is also O of m plus 1. Therefore, both space and time complexity is O of m plus 1. Therefore, we'll go through the further methods which actually will be a better solution when compared to this. Therefore, the next solution to which is more optimized than this is I would like to call it as a divide method. Therefore, let's see how we actually can divide the array. Let me go back to this. Therefore, to understanding the dividing method, let me take a larger array so that at least when I divide, there are few elements in both sides, right? Therefore, let me assume that nums1 is 1, 4, 7, 9, 11 and 21, and nums2 is 3, 8, 10 and 15. Okay. Therefore, one array is 6, the other array is 4, and totally the total size actually is 10. Right. Therefore, this is a even total number of elements is even in this, and we'll also go through how we can do in an odd method. Okay, therefore the way it works actually is if there are two sorted arrays, right? Now let me try to combine them, and we'll try to see, let's reverse engineer the whole method, right? Say 1 3 the merged array would be 1 3 4 7 8 9 10 11 15 and 21, right? Now therefore the way I can find the median actually is if I have 4 elements on one side and 4 elements on one side, right? Therefore basically these two form the middle two elements. Since the total number of elements is even, we will have 2 elements in middle. Therefore 4 elements on this side and 4 elements on this side. Therefore this is how we can divide it, right? Therefore 8 and 9 actually form the median, and the real median value is 8.5. Therefore if you see the same thing, right? If I see 1 3 4 7, okay, therefore let me see, therefore 3 is on one side, right? And 10 11 15 and 21 are on one side, right? Therefore say for example if I divide this in such a way that, right, I divide here and I also divide it over here, right? Therefore if I divide at this particular point, then what would happen? Therefore I would have 5 elements on this side and 5 elements on the other side. And if you see, right, 1 3 4 7 8 are on one side. Therefore if I exactly divide it over here, and 9 10 11 15 and 21 are one side. Therefore basically if we divide the sorted arrays in such a way that, right, in like for example in this particular case, right, then it is possible that actually we can, without even getting the merged array, right, we can still find out the median. Okay, therefore in this particular case, right, when I divide it in this particular way, therefore we always know 7 is always less than 9, right? Because the number over here is always less than here because it's a sorted array, and number over here is less than here, that also we know that because it's a sorted array. The other condition also which comes is this number, right, should be less than this number, right, and this number should be less than this number. When this particular condition is satisfied, right, then it means that we have divided both arrays in such a way that we know the left hand side of this division, right? All the numbers are smaller than the right hand side, right? Therefore this we can easily make a assumption of that. Therefore this is how we could do it. And later, right, how do you find the median, right, once you divide? That is the next question we will see later. Therefore now the idea is that how do we divide the arrays, right? Therefore let's see when we don't divide it properly, right, does our conditions get satisfied? Therefore what I will do is I will again write down those arrays actually, and this time I will not divide them properly to see. Okay, it is 9 11 21 3 8 10 and 15, right? Now say I divide somewhere over here. Okay, therefore while dividing there is another thing, right? We have to divide them equally. You can't divide something like this, say, right? Then what would happen? On left hand side there are only 3 elements, but on the right hand side there are bunch of around 4 plus 3 7 elements. Therefore this is not equal division. Therefore that's the other condition which we also have to satisfy. Therefore say I divide it over here, I decide to divide it over here, then how many elements are there? 1 element on this side, right? And there are 3 elements on this side. Therefore finally, since the total number of elements is 10, right, I need to have 5 and 5 on both sides. This side 5 and this side 5, just like how we have here, right? Same thing. Now since 1 element is there, therefore I have to have 4 elements on this side. Therefore I have to divide it here. Then what will happen? 4 elements on that side and 2 elements on this side, and if you see they are 5 and 5. Okay, now this division has happened. Now let us see whether all elements are left hand side and right hand side, does it satisfy our condition, right? What was our condition? Therefore this we already know, right? 9 is smaller than 11, this already is there. 3 is smaller than 8, that is there, right? Now that is not our interesting thing, right? The real interesting question now is actually whether this element is smaller than this. No, 9 is not smaller than 8, right? Therefore the first condition is not satisfied. 3 is smaller than 11, which is fine. Okay, this is fine. Yeah, 3 is smaller than 11, this is okay, but this condition is not satisfied. Therefore we know that the division has not been done correctly. Okay, this is the division method. Therefore the condition, right, this is a very important condition that has to get satisfied to know that the division has been done properly. Therefore if it is not done properly, we know how it is not done properly. Okay, now the way the solution, right, therefore I want to divide, basically I have two kinds of divide solution. Therefore one will be simple linear division. Okay, I'll explain you what does that mean, linear division. Okay, and other one actually is the binary division. I'll call it as a binary division. Okay, now to understand linear division and binary division, right, therefore see, if you see, right, there are two arrays for us, nums1 and nums2. Therefore it is possible that both the arrays can be of equal size, nums1 can be bigger, nums2 can be bigger, so on and so forth, right? But in the division method we always have to divide one of the arrays first and then calculate where is the division of the other array is happening, right? Therefore the first array where we are dividing has to happen always in the smaller array. Let me tell you the reason why is that, right? Therefore to get this equal division, right, we need to always divide the smaller array. If you divide the longer array, right, the problem what will happen is you'll be left with lot more. You can't divide it equally. That's a problem that will happen. Say for example in this particular division, right, say let me again do it over here itself to just to illustrate to you, right? Say the same, right, division, I do it say somewhere here. I'll first do the division of the longer array, right? Then what would happen? Therefore I need 5 items on both sides, right? Therefore I have only okay, I think it would still satisfy here in this particular case. Okay, but still we'll go through it, right? On this side there are already 5 elements, on this side there is only 1 element, therefore I have to divide it over here. There are no elements on this side. This is also a proper division. But as you can see, right, it's quite possible that you will run into place where you can't say for example I divide somewhere here. Okay, then there are 6 elements here. Therefore there is no way in which I can divide the other array so that it can be equally balanced, right? That's just not possible. Okay, therefore this is one thing. Okay, now we have talked about even number of total elements, right? Now I told we'll go with 2 methods. Let me explain the method and let me also explain later how do we do it for the odd array. Okay, therefore the first assumption, right, is that we always will start dividing the smaller array. Okay, not the larger one, the smaller one. Okay, and I want to introduce how I will solve. Therefore this array I'll call it as a Q and this array I'll call it as a sorry, the other way around. This array I'll call it as a P array and Q array. Therefore whenever I get nums1 and nums2, I will assign pointers to P and Q such a way that P always points to the smaller array and Q always points to the larger array, so that my confusion is gone. Therefore this is one assumption I am going to do. The other thing what I want to talk to you about is in the linear division, right, I will divide the P array, right, in all possible ways, right? Therefore how many times I can divide? Therefore I can divide over here so that there is no left element. I can divide over here 2, 3 and 4. Therefore if there are 4 elements in a array, right, then I can do 4 different divisions are possible. Therefore this is one thing I want to talk about. Okay, therefore I'll divide here, then I will see whether my condition of median, right, is getting satisfied. Then next I will go and divide here, 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 here. Whenever that condition gets satisfied, then we exactly know that we have the median. Okay, therefore to again go back, right, to understand the median over here, right, therefore if you see in this particular case, right, what was the median finally, right? Median was actually the average of 8 and 9. Therefore if you go back here, right, I have 4 numbers over here, right, 7, 9, 8, 10. Therefore how do we know what is the median here? Therefore the median actually is, if you see in that way, the 7 comes over here, 8 comes over here, right? 7 comes over here, 8 comes over here, and 9 comes over here, and 10 goes over here. Therefore it is very, very intuitive, right? The number which comes in the middle is actually the maximum of these two, right, on the left hand side, and the minimum of these two, right? Therefore that is my median. Therefore we will write the formula later, having the proper notation, everything, but yeah, this is how the median is calculated. Now coming back to the odd number, right? The odd number will do the same kind, same logic of dividing the arrays, but one thing what will happen with the odd number is that you can't divide them equally, right? Like 5 and 5 on both sides, that is not possible. Therefore the way we will divide in odd number is that one side it will be, say for example I have totally 9 elements. Let me take one more example. Let me make one of the arrays short and explain you that, right? Say for example I go with the same array, but let me make one of them short. 1, 4, 7, 9, 11, 3, 8, 10 and 15, right? And I know the resultant array. Therefore the resultant array will be somewhere 1, 3, 4, 7, 8, 9, 10, 11 and 15, right? This is the resultant array, and the median here in this case, right, is 8. The only one element is the median, right? Because this is a total is odd here. That is the reason. Now while dividing, right, since there are totally 9 elements, I can't divide them equally, right? Therefore what I will choose to do is I'll try to divide them 4 on one side and 5 on the other side, right? 4 on one side and 5 on the other side. Even though they are not exactly equal, it is fine with us, but the only difference should be 1 with them. Okay. Now in this case, right, to find out the solution, I'll exactly go to the solution and see what happens, right? Therefore I will say divide it here, and I will say divide it here, right? 2 on one side and 4 on other side. 4 on this side, right? Therefore if I divide it here, right, 4 on one side and 5 on the other side. And do we have, no, I think this is not the right division, sorry about that. Therefore let me write the 7 back. Therefore I think the real division is between 3 and 8 and 7 and 9, right? Therefore on one side we have 4 items, and on the other side we have actually 5 items, which is okay with us. But if you see here, right, now what has happened here is on one side we are taking 4 elements, right? Finally if I represent them in the resultant array, and one side there are 5 elements. This is how we are going to we have divided it, but the same condition is getting satisfied. That is what I want to bring. 7 is less than 8 and 3 is less than 9. In other condition this won't happen. Okay, now what is the median, right? Once I have divided them, but not equally now. One side is heavy, that is fine, but I know that the heavy side will have the median now, right? Because if I divide it along 8, then I have 4 and 4 elements. Since there are 4 elements here and 5 elements on this side, the median is the minimum, right, in this array, whichever is the minimum in this array. Therefore it is very, very clear now. In case of odd number of elements, we need to just find minimum of these 2 elements and return it. That's it. Therefore this is how for odd we are going to solve it. Therefore we'll go with a linear division at the moment. Starting with first, we'll keep on dividing, but we'll also see the binary method of it, right? Binary method of course will be more efficient of it, but to understand the nuances, right, we'll not directly go into binary. We'll go to linear method first and then the binary method. Okay, now let's try to go to our editor and start solving it. Therefore this older method I would still keep it somewhere. Hash if defined, say this is to index method, okay, and in the else part I'll write now the linear method, and binary method would be very similar to that, but yeah, regardless of that, let's see. Therefore I won't copy the whole stuff because it's totally different implementation. It's not a small change on the the toIndex method. Therefore the first and foremost thing what I need to do, right, when I get this is I need to have P and Q, right, sorted out. Even before that, right, I need to handle some special cases before I go further, right. Therefore one case is we already talked about in the previous method, right, that was when both of them nums1 and nums2 are null, right, then we need to return 0. Therefore let me copy this. There is no resultant array here, therefore we are saving a lot on space. Therefore, right, if nums1 equal to null as well as nums2 is equal to null, then we directly return. Therefore the another possibility, right, is where we need not do much calculation, right, is actually when nums1 is null, right, say, or nums1 size is less than 1, right, it means basically it's at 0. There is some okay, there are extra brackets over here, that's fine. Okay, in this, sorry about that, yeah, in this particular case, right, now the median calculation is very simple to me, right. Therefore what is a median? Median is nothing but the middle element of the nums2, that's it, because there is no nums1 at all, right. The median is nothing but the middle element of the nums2. Therefore this we already know, right. How do we calculate that? It is nums2, right, divided by the total element, which is again nums2 size minus 1, right, divided by 2, and plus nums2 of nums2 size divided by 2, right, and the whole thing we have to add and divide it by 2.0. Therefore this is very simple. Then the other interesting condition is, you would have guessed by now actually, when nums2 is null, right, then, or the nums2 size is less than 1, either one of the condition, then we return the mid element of nums1. Therefore that can be very directly done. Therefore this same condition I could have done earlier also, but I didn't do because the idea was not like to have very optimized solution as such, right. Therefore these are the basic trivial conditions, right, which I have handled here. Okay, now let's go through further. Now we need to find out P and Q, right. I need to have two arrays. Therefore let me declare them P and int star Q. Oh, sorry. Therefore the way I want to do is, I'll assume P as I need to also allocate for P size and Q size. I'll assume P is equal to nums1 and I'll do the other condition later. Okay, therefore P size is this, therefore this is nums2 size, this is Q size, Q is equal to nums2. Okay, next condition I'll check is if, right, nums1 size is greater than, or if it is the other way around, right, nums2 size, then what do I do? Now I will assign P and Q in the reverse way, right. Therefore first I will assume them that this one, I don't want a if else condition here. This is one way of doing it, right. Therefore nums2, this is nums1, this is nums2, and this is nums1. Therefore now exactly at the end of this execution I'll have P that is pointing to always the smaller array and Q which is pointing to always a larger array. Therefore this one thing is out of the way. Next, right, what do I do? Now I have to divide the array, right. How do I divide the array? Now here is another condition, right. Earlier if I go back and Therefore the division, right, doesn't look exactly like this when we program. Therefore this is where actually there will be some sort of a difference. Now when I was talking here, right, let me go to the same question, sorry, the example which I took earlier, right, which was yeah, therefore I had 3, 8, 10, 15, 1, 4, 7, 9, 11, 21, right. Therefore earlier I could tell that okay, I am going to divide over here and I am going to divide another one here like this, right. But in programming, right, I can't tell divide something along these lines, right. Therefore say this has index 0, right, 0, this is index 0, this is 1, this is 2, this is 3, right. Therefore I can't tell okay, divide between 1 and 2. The representation in the programming will not be that easy, right. Therefore the other way of representing it is actually I will divide along the indices itself. Okay, therefore if I tell I am dividing along 3, it means that I am having my what you call I am representing this index to be my left divide. Therefore say if I am okay, let me do it the other way around, right. Let me explain you in this way. Therefore say if I am telling that I am going to divide over here, it means that the index which I will use is the index of 10 while dividing it. Therefore if my index, the dividing index points to 10, it means that I am going to have these as my right element, the 10 will be the right element, and whatever is the index of it, right, in this case 8 will be my left element. Therefore if I am dividing here, right, I will be pointing my index here. This is another thing we need to understand. Okay, this is very, very important because we can't divide in between. That representation, that notation will become very, very complicated, and that's not worth spending time over. Okay, therefore now again let's go back now to the coding, and now how do I divide now, right? That is the next question which I have, right? Therefore what I will do is I have to loop through P now, right, because that's how I have to divide it. Therefore let me have a iterator, right, index for that, and for I is equal to 0 and I less than P size now, size, and I plus plus, right. Therefore this is how I am iterating now. Therefore I have to iterate till the end of the size, right. Therefore I have to go I is less than or equal to P of size, because I had told you earlier also, right. Therefore if I have 4 elements, I have to iterate 4 times, 5 times actually, one more than this one. Therefore that's why I want to have it like this. Next let me have J to calculate the other division, right. I is basically dividing along the P and J is dividing along the Q array now. Therefore J of course will be equal to the P size plus Q size divided by 2 and minus I, right. Therefore P size plus Q size actually by 2 will tell me, like if it is 10, right, the whole size is 10. If the two elements are say 7 plus 3, what we had right earlier, is 10. Therefore 10 by 2 is 5. Therefore initially it will try to divide it along all 5 on one side and the other one will be 5. Therefore this is how we are going to divide it, right. Okay, the next, right, is therefore I have now divided the array. Now I need to find if the array is sorted, right. Therefore to find whether the array is sorted or not, right, I will write a condition to do that. If, right, is sorted, I will call this as array as this one, and I will pass P size to it and the index I, and Q size to it and index J, right, where I am dividing, and it will return true if it is, if this condition, right, of I was talking you about the condition, right, where the numbers have to be less than to them. If that condition is satisfied, then it will return true. In that case, I'll break the for loop because I know that I'm done, and then I have to find some ways to find median here, right? I'll write that code later. Therefore, let's now write the is sorted array. Okay. Therefore, is sorted. Therefore, it takes p array and the p size as an input, and int what you call the I, and q array and q size and int j. Therefore, it's taking all of them, and it is returning a bool. Okay. Therefore, if I am returning a bool, I have to include std bool here, bool.h. Okay. Now what do I write in this is sorted, right? Therefore, here again there is a little bit more complication, is that I need to find, when I divide it along I or j, right, I need to find what are the left and right elements along that division. Therefore, index I is dividing it, right? What is the left and right along that? Therefore, I need to get int left on p, right on p, right, and left on q, and right on q, right? These are the four things I need to find it. Therefore, how do I find it, right? Is that is very simple. Therefore, to find p left and p right, what can I do is I check the index. If, say for example, if I is equal to 0, right, it is at the first division, right, then I know what is a p left. P left actually is nothing, right? It is out of the array. Now I have to give some value to it, right? Therefore, I'll give int minimum, right, because it will take the most minimum number of possible. Therefore, if there is any comparison there, I don't want that to be selected, right? Therefore, I'll take this as int min here. Okay, and p right is nothing but p of I, right? And the same case, else if say I is equal to p size, then what would happen is p, I know p left to be equal to p of I, which is at the end, right? Or p of I minus 1, because we are at end of the array, right? Yeah. And the right one, p right is equal to int max, right? Because there is nothing there, right? In a sorted array, the most minimum number we'll assume, if it is going out of the array, we'll assume the most minimum number on this side, on the left hand side, and we'll assume the most biggest number on the right hand side. That's our assumption. And in any other case, right, in any other case, it is very, very simple, right? We know p left to be equal to p of I minus 1, right? And p of right is equal to p of I, right? And I think I have to do the same thing to the left also. Therefore, instead of doing that, I'll write a small function called as get pair, and right, say this returns a void. It doesn't return anything, right? And instead of p, I'll call this generic array as a array or something like that, right? And what it does is it returns 2 indexes to me. If I have to pass pointer to that, right, and I'll call them as left and int star right. Okay, therefore this is a function I have to write now. So this is very similar to whatever is here, right? Therefore, instead of p left or p right, it is replace string p with nothing. Let me write a here. Therefore this has to be right, not 8. And these are all pointers, therefore I have to dereference them right here. And I just return here, it's a white pointer. Therefore here, to get p right and p left, I can actually remove all of these stuff and just tell get pair, right? And what do I need to send? P and p size of that, and where it is dividing it, and my two addresses, right? P right and p left. Okay, same thing I'll also do for the Q array, right? Replace string p with Q, and here it will be J, if I'm not wrong. Now if it is sorted, right, then what would be my condition? It would be that p left, right, whatever is on the p, the smallest array, will be less than or equal to Q right, and Q left, right, also should be less than or equal to p right. Therefore this is my condition, and in this case I will return true, and if this is not there, right, in the else part I will return false. Okay, and yeah, this is it. If I need not have a return statement in the end, is sorted. Okay, now I know when it gets sorted it will come here. Now I have to find the median. Therefore let me write a function for that, right? Get median, and the same thing, right? Whatever I was passing here, I have to pass it again here, right? And let me write those. Okay, let me find. This is very similar to this, therefore let me copy the prototype of this. I'll write somewhere over here, right? Therefore this should return a double, right? And it is called get median. Therefore same thing, I need to still get my left and right pointers here also, right, to decide whether what do I need to do, right? I'll get them. Then after that I need to have condition that if p size plus q size, right, if it is odd, I divide it by 2, and if it is odd, then I have to do the one condition, else it is the even condition. Therefore let me write the even condition first and then write the odd condition. Therefore I need to find max and min. If you remember, right, it is max. We need to write max and min here. Therefore let me quickly write them over here, and starting yeah, hash define, right, max of say x and y. I take two variables. Therefore the first thing I do is I take x, I compare if it is greater than y, right? If that is the case, then I return x, otherwise I return y. The min is very similar except that I check for less than, right? There is a convenient notation to do this. Okay, sorry, I went past it. Okay, therefore in the else case, the median, right, will be median will be the average of, right, whatever is on the p left and maximum of maximum of p left and q left plus minimum of p right and q right divided by 2.0. Therefore this is my median. And in case of odd, the median is nothing but minimum of whatever is on the right side, p right or q right. Yeah, I think everything is in place. I think for int max I have to include limits.h. Yeah, therefore the driver function will remain the same. Therefore let's try to compile now and see what happens. There is an error, I equal to size. Okay, where is this? In get pair. What is the mistake I did? Let me go to get pair. Get pair. Oh yeah. This has to be a size, right? Yeah, I think it had even given the suggestion here telling that are you meaning a size. That's nice. Implicit declaration of get pair. Oh, somewhere I have done queer. Okay, QUAR. Oh no, sorry. Wow. Okay. Therefore this has to be pair. I think same mistake I would have also have done in get median also. Okay. Okay, now let's run it and see what happens. Oh no, we are getting a very huge number. Then it means that we have done some mistake. Therefore let's see where the mistake is. P right and Q right. Therefore in this particular example, right, we have actually even number therefore we have actually even number of numbers here, right, on both sides, 1 2, and therefore it is 2 plus 3 divided by 2. That is what we are expecting, right? We have to divide it along those lines. Therefore where have we gone wrong? Q left. Oh wow, in get pair I'm actually asking right and left, but I am taking here left and right. Okay. Okay, it should ideally be left and right if you ask me. Yeah, it doesn't matter. Let me try to compile it again after this fix. Yeah, now we are getting the answer. Now let's submit this particular solution and see in the lead code and see how better it fares when compared to the previous solution. Oh yeah, till here. Okay, therefore let me paste it here and run the code once. It is accepting, therefore let me submit it. Okay, I'm getting a wrong answer. For what? For 1 2 minus 1 3. Okay, yeah, so there was a issue. Therefore I debugged it for some time, and I finally figured out that Q left was not given. That's why it was not working. Now if I resubmit the same code back after the modification, now it is accepting it, and this is for some reason not giving better performance. But of course this is a much better solution compared to the last time. Maybe since there are a lot of functions involved, maybe that might be one of the reasons. Therefore one way I can think of doing it is making them all static inline and try to see if that helps in getting better performance. It should not matter actually. I'm not sure why that's the case. Nevertheless, I have made everything static inline now. Let's resubmit it and see if we get better performance now. Let me run the code once. Oh, there is a printf. Okay, yeah, while debugging I had introduced a printf. I think this is ruining the performance. We should not have any printfs. Let me copy it back. Let me run the code. Okay, now I think we should get much better if everything goes fine. Yeah, see, if you see here, right, it is almost at the top, and even the memory usage is very less compared to the other thing. Therefore, the next on top of these, right, we can improve it further. This actually goes through a linear search, right? Therefore, this particular function can be improved, and we can actually, instead of doing a linear search, right, we can do a binary search here. Okay, therefore I'll make as hash if defined linear, this is a linear solution, else we'll have binary solution. And let me copy the whole thing here because I will be modifying on top of this. I'll not be doing something drastically different. Okay, therefore now instead of what you call linear search, we'll do a binary search, right? Therefore binary search of course would involve finding the middle, end, and the start, right? Therefore let me have those also here, mid, start, and the end, and let me initialize all of them here, right? Therefore the start will always be at 0, right, and the end will be always be at the end of the array, which is p size, and the mid calculation will be always be start plus end divided by 2, right? Now instead of using a for loop, I would like to use a while loop here because that is more convenient, and the condition is that the mid should never be should be always greater than or equal to 0. It can't be negative, and the other important condition is that mid should never overflow the end, right? It should be always less than or equal to the p size. This is our condition. Now the first thing we'll do in the while loop is, now I know what is I, right? I is always the mid. Therefore I divide exactly at the midpoint of the first array, and j calculation is same as that before. There is no change there now. Okay, let therefore now we need to, if the array is sorted, then it is fine, right? If the array is not sorted, let's assume, right, then we need to actually adjust the midpoint now, right? Adjust the midpoint over here and again iterate it. Now where do we want to adjust the midpoint? To understand this, actually we have to go back again to our notes and try to see, right, where do we adjust the midpoint. Therefore let me open my tab again. Yes, therefore say I have a array, right? Let me go back to the drawing mode. Let me erase off all the stuff till now, okay, so that I get a clean sheet. Okay, say I have 1, 2 and 5, and I have say 3, 4 and 6, 7. Okay, in this way. Say now I have divided it, right? I have to divide it somewhere. Say I have divided it along 1 and 2. Okay, therefore the total element, if you see, right, it is 3 over here and 4 over here and totally 7, right? Therefore totally 7 elements are there. Therefore I have to divide them as 3 and 4 again, right? Therefore say if I have divided along here, therefore there is 1 element over here and 2 elements on this side. Therefore, but I want 3 and 4, right? Therefore I need 2 more elements on this side and 2 more elements on this side, right? Then it will be 3 and 4. Okay, this is again a side calculation. Okay, this is how I have divided it. Now say for example, now I compare, right? Is 1 less than 6? Yeah, fine. But is 4 less than 2? No, it is not, right? Therefore 2, right, is actually less than whatever is here. 2 was supposed to be a higher number, but it has become a lower number. Then we know that we have to divide it further along this side. Therefore basically the midpoint, whichever I selected, was on this side, right? But now it has to go on this side. If I find the other way around, right, then I'll move it on this side. Therefore I need to actually do a array comparison over here basically, right, whether how should the midpoint be traveling. Therefore let me quickly write down that, okay, to adjust the midpoint. Therefore say for example I have one I write a new function. Therefore let me think of function and then we'll see what happens, right. Say for example I have a function called as array comparison, right. It will exactly tell me whether I have to go to left or right. Therefore this again would take p and p size, and where I am dividing them, I am dividing it along I, and I am also dividing q size, and I am dividing it along j, right. Therefore these are the parameters to the functions. Now if say the return value of it is say 0, right, if it had returned 0, then it means that I have found the exact sorting condition, okay. In this case I will break. Therefore now I don't require is sorted at all, right, because I know now that I will directly adjust the midpoint, also find whether it is sorted or not. If else if, right, if say the return value is say negative, any negative number, then it means that I have to now move my what you call, towards the left hand side, because it's negative, right, it's telling me to move towards the right hand side, and if it is greater than 1, it means that I have to move to the left hand side. This is the assumption I am making, okay. If it is greater than 0, then it means that I have to move to the left hand side. Therefore this is towards right and this is towards left, okay. Therefore if I have moved towards the right hand side, then what will happen, the end then will become the new end will be the move towards the midpoint, and the mid will be recalculated. Therefore in this case, right, when I am recalculating the midpoint, since it is towards right, I will subtract 1, okay. This is for the indexes to align actually, and if it is towards the left, I'll make start as the midpoint, and the midpoint again is recalculated as start plus end. Now I have to increment it by 1 again for the index calculation, okay. This is the condition. Now there is no else condition possible because it should be one of them, right. I need not have put this also, but still for good reason. Therefore instead of now is sorted, I want to write it as a array comparison, right. Therefore let me just rewrite the same function is sorted into array comparison. Where is sorted, get median, get pair, yeah, this is a is sorted. Therefore I was returning a bool. Instead of that, now I will return integer, right, and I will do the same thing here. Instead of here, I'll return it as 0, and I have two other conditions, right. If the other condition is if, right, if else if, in this one, if p left is greater than q right, in that case I know that I have to move towards the left hand side because it is less, sorry, towards the right hand side, else I will return 1, okay. Therefore I have just modified the is sorted, and I'll rename it to array comparison now. Therefore let's see now how, let's compile and see what happens. I think I'm not am I getting the right answer? I'm not sure. Let me just check it out. Yeah, -1 1 2 3, therefore it's 1.5. yeah, it's absolutely correct, okay. Therefore yeah, let's run it and see what happens now. Let me copy the code and then submit it to, no, I have to copy till the, because all solutions are in one file. It's little becoming confused. Okay, this is the This is the midpoint solution. Yeah, therefore I have to go till this end. Okay, let me quickly run the code here and see whether it works for this solution. Okay, it works. Let me submit the code. Yeah, it is showing it as 90% and old one as 98, but this is much faster, we know, because this is using the binary search. Yeah, thank you for listening. Hope you like the video.